All right, viewers, welcome back to my YouTube channel. Hope by the grace of God you are doing well. All right, today we have a question on the board under Kirchoff theorem or the Kirchoff current law. Now, let's see what the question have for us and see how possible best we can work. The question says, use Kirchoff law of current to solve current problem. Show working by proving your answer. Now, as you can see on the board, we have two of the current that are entering into the node and two of the current moving out of the node. Let's see the current that is moving in and the current that is moving out. We can see the arrow at current 1, arrow at current 2 entering into the node. The point here is called the node. And we see I3, current 3 and current 4 moving out the node. The arrows are going out. So we have a general formula for finding current law under Kirchoff. So this is the general formula. Current in is equal to current out. So this is the general formula. And as we can see, I4 is unknown. So we are looking for I4. So let's say current in is what? I1 and I2. So you write I1 plus I2 is equal to current out is what? I3 and I4. They are going out. So I3 plus I4. So let's put the values. I1 is what? 6 amps. I2 is 3 amps. I3 is 4. I4 is unknown. So this is unknown. So 6 plus 3 is what? 9. So we have 4 plus I4. So I4 is equal to 9. When this 4 cross the equal sign, it becomes minus 4. So I4 will give us 9 minus 4 will give us what? 5. Will give us 5 amps. So this becomes our answer for I4. Remember, we are asked to show working or prove our answer. So assuming, so here I4, we have what? Our answer as what? 5 amps. All right, so let's say, assuming I4 we know is 5, I2 we know is 3, I4 we know is 4, but we don't know I1. So assuming we don't know I1, let's prove by what the question says we should prove the answer or show working. Let's prove and see whether we can prove and see whether we will get 6 amps. So we are looking for I1 now. So let's put the formula I1 plus I2 is equal to I3 plus I4. So I1 is unknown. I2 is what? 3 plus 3 is equal to I3 is what? 4. I4, now we have the I4 there as 5. So I1 plus 3 is equal to 4 plus 5 is 9. So I1 is equal to 9. When this 3 cross the equal sign, becomes minus 3. So I1 is equal to what? 6 amps. You see that we got the same answer as 6 amps. All right, so let's assume that I2 is unknown. Let's assume that I2 is unknown. So you put the formula I1 plus I2 is equal to I3 plus I4. So I1 is 6 plus, so let's assume that I2 is unknown. So I3 is 4, I4 is 5. So 6 plus I2. So 4 plus 5 is 9. So I2 is equal to 9. When 6 cross the equal sign, become minus 6. So I2 will give us 9 minus 6 will give us what? 3 amps. You see that we got the same, arrive at the same answer. So let's see, now we got I4, which is this. We got I4, which is this. we got I1, which is this. We got I2, which is this, by proving or by show working. Now we are looking for what? I3. So now we are looking for what? I3. So let's put the formula I1 plus I2 is equal to I3 plus I4. So I1 is what? 6. I2 is what? I2 is 3. I3 is 4. Okay, so we are looking for I3. So I3, so plus I4 is 5. So 6 plus 3 will give us 9. So I3 plus 5. So I3 is equal to here 9. Once this 9 cross the equal sign, becomes minus 5. So I3, 9 minus 5 will give us what? 4 amps. So you see, by proving, which help us to see that what we have worked is correct, tells us the I4 that we work for is correct. By proving, by checking whether I1, I2, I3, we have seen that. So this I3 is also worked. So this is the answer when it comes to current law. I will show you another example in the next video, but for now, this is the answer. Maths is a fun. It is not difficult. Just take your time, follow the steps, and you will understand. All right. After the current law, I'll give maybe about 2 or 3 or 4 examples about currents in Kirchoff law. Then maybe later, at the end of the current law, I'll give you the voltage law. But for now, this is the answer. Well, comment below, subscribe, share my video, and like my video. And I tell you, don't worry, maths is a fun. Take your time. Just take your time and work it out, and you will get your solution. Right, as usual, sow your today and reap your tomorrow. Bye-bye.